Space exploration has evolved dramatically over the decades. In the early days of our ventures into the cosmos, our knowledge of rocketry was limited. Government agencies like NASA pioneered the path, and every announcement or update they presented was widely accepted. The costs associated with these early missions were high, but most believed this was simply the price of space missions. Fast forward to the present, and the landscape of the space industry looks vastly different. Government-run space agencies now share the stage with private companies, with firms like SpaceX leading the charge in innovation and cost-cutting. Consider NASA's Space Shuttle program, which was used to transport astronauts to the International Space Station. Each of these launches had a hefty cost, estimated at over $1.5 billion. In comparison, Space's Falcon 9, designed for similar missions to the ISS, costs about $150 million per launch. This vast difference in costs between government and private ventures has sparked significant debate and questions. Interestingly, the evolution in space technology doesn't stop with SpaceX. There are companies like Relativity Space pioneering the use of 3D printing to develop entire rockets. Yes, you heard that right, 3D printed rockets. Such innovative methods could drive costs down even further. This brings us to NASA's latest project, the Space Launch System, or SLS, intended to be a cornerstone of NASA's lunar missions. It's now under scrutiny due to its rising costs, especially when compared to more cost-effective solutions from private companies. Some even debate its continuation. Is NASA in trouble? Let's find out. Before we delve deeper into this topic, remember to subscribe for updates on space exploration, including the latest on SpaceX's operations and the upcoming launch date of the Starship. NASA is facing significant criticism for its lack of transparency, especially concerning the rising and unchecked costs tied to its ambitious SLS project. While criticism is not new to the space agency, the increasing intensity and regularity of these concerns have put many on alert. In today's digital era, with information shared at lightning speed, the public has grown used to a transparency from aerospace companies that NASA seems to be falling behind on. For instance, companies like SpaceX have set new standards for openness. Almost every test or major event at SpaceX's Starbase is live-streamed, offering an unparalleled level of engagement. Not stopping at just broadcasting, SpaceX often allow media personnel and space enthusiasts to set up camp nearby, capturing every possible angle and ensuring the public stays informed in real time. This openness from private companies has changed what the public expects from space agencies. Adding to the concerns, the Office of Inspector General recently released a detailed report examining NASA's oversight and decisions related to the SLS. The results were troubling, highlighting repeated errors and too much optimism about the SLS's abilities, longevity, and cost-effectiveness. With private firms setting new standards for transparency and efficiency, NASA's traditional approach is under the microscope, pushing the agency to rethink its methods and how it communicates with the public. The primary concern with the SLS doesn't revolve around its performance or capability. Indeed, its inaugural launch in 2022, known as the Artemis 1 mission, was virtually flawless, even if there was minor damage to the launch tower. The primary concern is its exorbitant cost. About 10 years ago, Congress commissioned an independent assessment to evaluate the fiscal feasibility of NASA's ambitious projects. The findings were quite stark. Based on the projected expenditures for the SLS, the report indicated that NASA would face significant challenges in sustaining a long-term deep space exploration agenda if it continued to depend exclusively on such an expensive heavy-lift rocket. The financial breakdown of the SLS provides a clearer picture of how its funds are allocated. One of the most significant expenditures is the rocket's 4 main engines, which were repurposed from the legacy Space Shuttle program. These engines carry an astounding price of $582 million each. To draw a comparison, the cost of just one of these engines is almost equivalent to the entire launch cost of a SpaceX Falcon 9 rocket. What's even more notable is when you compare this to SpaceX's Raptor 2 engines. These engines, celebrated for being among the most advanced rocket engines ever crafted, are priced far more competitively, highlighting a significant cost disparity when compared to the engines of the SLS. Amidst rising concerns about the soaring costs, NASA presented a strategic roadmap. Their vision involved transitioning to a service contract system, aptly named the Exploration, Production, and Operations Contract, or the Exploration Contract. This fresh approach was to kick off with the Artemis 5 missions scheduled for the latter part of the 2020s, and the driving force behind this initiative was the deep space transport venture. Many viewed this plan as brilliant, to slash the astronomical SLS costs by a jaw-dropping 50% or more. But the reality, as sketched out by recent findings, doesn't seem as rosy. The forthcoming Block 1B iteration of the SLS, slated for its majestic debut with the Artemis 4 mission, carries an initial price tag of $2.5 billion for each expedition to the cosmos. Now, even if NASA were to achieve the ambitious 50% cost-cutting goal under the exploration contract, the math is still daunting, about $1.25 billion for each journey skywards. Furthermore, there's the issue of the SLS's engines. Even though they are the most expensive component of the SLS, the report sees no feasible way to decrease their costs. Efforts to introduce manufacturing efficiencies, such as 3D printing and the use of more affordable materials, haven't delivered the expected cost reductions. To put it simply, imagine trying to switch from brand name to generic products at the grocery store to save money. At first, you might think that you'd save a significant amount just by choosing the cheaper option. However, if those generic products don't last as long or don't meet your needs as well, you might end up purchasing them more frequently or supplementing with additional products, ultimately not saving as much as you initially thought. In a similar vein, NASA's attempts at cost-cutting for the SLS, even with seemingly promising technologies, haven't translated into the expected savings. The Space Launch System is currently the only rocket that can launch the Orion spacecraft. However, within the next 3 to 5 years, alternatives are expected to emerge, with SpaceX's Starship program leading the charge. SpaceX's Starship is designed to be different. Unlike the Space Launch System, which has high costs associated with each launch, Starship is being developed as a fully reusable system. This means it can be launched, landed, and then launched again multiple times, potentially reducing the cost of each individual mission. Comparing Starship and SLS directly, the differences are clear. The SLS, though powerful, comes with significant costs. Its economic model seems outdated, especially when newer commercial ventures emphasize efficiency and cost saving. On the other hand, Starship's design prioritizes reusability and aims to have a higher payload capacity than the SLS. If successful, this could lead to more cargo and astronauts being sent to the Moon or Mars at a lower cost. With burgeoning commercial players like SpaceX and Blue Origin offering potential alternatives, NASA may have to reconsider its approach to deep space exploration. Balancing fiscal responsibility with ambitious exploration goals is no small feat, but it's an essential task for ensuring the future success of space missions. And that's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.